Thank you very much for joining my session this morning. My name is Manuela, and I am a junior software engineer at Brickfest. I'll start by telling you a little bit about my background so you can have an idea. I do not come from a technical background. I used to work in the travel industry and decided to transition into tech a couple of years ago. And I kind of slowly worked my way towards that goal. And I ended up joining a bootcamp that I graduated from at the end of 2019 during the pandemic. And I managed to secure my first role about 2 months later, so just over a year ago. The role was actually advertised on the Codebar website. And this is such a great and supportive community that I guess in a way, this is my way of giving back by having this talk today. I do hope you enjoy the talk. And if you have any questions, please write them in the chat, and I'll try to try my best to answer them at the end of the presentation. So my topic today is about content security policies. This is a topic I knew nothing about a year ago when I was just starting my career as a developer. As this is a beginner level talk, I will just be walking you through some basic details about content security policies, like, for example, what it is, why do we need it, how it works, how to implement it, and if there's anything to avoid or keep in mind when writing our content security policies. So, just like everyone, no matter how much experience you have, we use Google a lot. So I went on Google and I Googled the definition, I guess, of content security policies. So according to MDN Web Docs, content security policy is an added layer of security that helps to detect and mitigate certain types of attacks, including cross-site scripting, which is XSS, and data injection. Now, if you are a novice like myself, the definition might be a little bit unclear. So I'll take a step back and explain what happens during an XSS attack in order to better understand the role of having CSP in place. So I think this diagram here explains this fairly easy, but I'll go through it. So the hacker injects your website with a malicious script. And when your client or your victim visits your website, it triggers that malicious script on your platform. So then the victim's browser executes that script and unknowingly forwards their sensitive information to the hacker, like, for example, session cookies, session token, and so on. So with CSP, we try to protect ourselves against this type of attacks. So this is the main role of the CSP. Now, why do we need CSP? So web security is rooted in the same origin policy. What does that mean? Same origin policy. So let's say I have a website and it's called myapp.com. What that means is that code from myapp.com should only have access to myapp.com data, and other applications should never be allowed access. Now, this is an ideal case, but in reality, we need to use third-party apps that can potentially leave us vulnerable, and attackers have found ways to break the system and exploit those vulnerabilities. So in our company at Brickfest, we work with third-party suppliers. So for example, we use this automated chatbot provided by Zoho. So basically, we don't want to build our own chatbot, so we are using the one from Zoho. So we allow Zoho to run their code inside our application in order for the chat to actually work. So for this reason, we have this CSPs in place that specifically defines what we allow. So we define that we allow content coming from Zoho and block any other type of code being executed on our website. So I'll go through a short example of how CSP works, just so you can have an idea of what happens in the background. So let's say a user visits your website. They go on the browser, they type myapp.com. When he makes that request, the first reply that he gets from the server is a response header. This is basically like an introduction from the server, and it's going to tell the browser what content he's about to receive. So when loading, the browser fetches the website's headers, and this is where the CSP is specified. The browser then parses the CSP and remembers which sources are allowed to be loaded. And then the rest of content is coming. So the browser now starts to load additional resources defined in the source code. So it basically reads the HTML, it reads the fonts that we've defined, the images, CSS, and that Zoho chat that we were mentioning earlier, and any other scripts that we wrote in our code. So each resource that is loaded is cross-referenced with the page CSP. And if a source is not specified, then the resource is blocked. So bottom line, CSP allows the browser to know what resources to allow and what to block. And I guess I can mention here that all modern browsers except Internet Explorer support the content security policy HTTP headers. Now, I'm going to go through a very short example of how to implement a CSP. I've just put there a little bit of code, and I'm using, so this code is written in Python, Qt framework. So Qt is very similar to Flask, if you've heard of it. And in this CSP, I'm basically defining policies for Sentry, Zoho, and Hotjar. These are just some third-party apps that developers might use on their websites. So let's have a look at this. It might kind of look a bit overwhelming, but it's important to mention that each third-party app that you want to use will have documentation mentioning what needs to be included in order to be correctly set up. So it's actually fairly easy to implement. You have to go through the documentation, and they will tell you exactly what you need to input in here. So I'll go through the ones I included here, but there's a lot more in documentation that you will usually add. So going through the example, you can notice that the CSP is split by type of resource. So you see there's a self. You have response content security policy, default source self. What self means is sources that have the same protocol as the file the content policy is defined in. Basically, it's our own scripts. So the simplest form of CSP you can implement is to mention that you only allow scripts from your own files and nothing else, and that's it. Just my own scripts and nothing else. Everything is blocked. This is the simplest form. And then everything else after self represents other sources that we allow content from. So for example, I say I allow default scripts from myself, the ones that I've written, and also from Zoho. Now, default SRC, the default policy is the default policy for loading JavaScript, images, CSS, fonts. Default SRC directive serves as the fallback of other CSP directives. So for example, for each of the following directives that are absent, the browser looks for the default SRC directive. So if you forget to, or you don't include anything about your style, then the policy will be going straight to the default SRC and looking there for direction or what to do. Now, everything else, I guess, is fairly self-descriptive. Script SRC defines valid sources for JavaScript files. Style defines valid sources for CSS files. Images defines valid sources for images, and so on. The other cool one that I wanted to mention here is the report URI. So report URI is a policy that you can actually keep track of the violation attempts. So if someone is trying to run malicious code on your website, you can use this report URI to send a notification. So in our case, for example, we use this tool called Sentry. So whenever there's a malicious attempt, we let Sentry know, and then Sentry will send us an email or an alert. Someone is trying to run some code on your website, and then we can basically investigate and see what happens and take action. So it's quite cool. Now, if you look at on the last line, you'll see this script from Hotjar, and it has unsafe inline. So some third-party apps that you might want to use will ask you to put in the CSP something that looks like the unsafe inline. And this kind of takes me to the last bit of my presentation, and it's about what to avoid with CSP. So the unsafe inline keyword cancels most of the security benefits that content security policy provides. So because it allows the use of inline resources such as inline elements. So I'll talk a little bit about this as well. So as I mentioned at the beginning, malicious attempts are done by running scripts. And I'm putting here below an example of an XSS injection. It's a very simple one, just kind of to prove the point of how you can do it. Inline scripts look like the first line of code. So when a script tag is used inside the HTML file, is called inlining. So this means that there's no external JavaScript file, and instead we're actually writing the JavaScript inside the HTML file. Now, modern coding practices have moved away from this way of coding, and customize structures to templates. So we now kind of usually write our scripts separately and have the JavaScript in separate files. So the code might look a little bit like the second line that I wrote there. So allowing code like in the first example gives the CSP a much weaker protection against XSS attacks. And it's the reason why it's prefixed unsafe. Now, having to type unsafe somewhere should be a reminder that we are doing something potentially dangerous. Unfortunately, although just mentioning that, unsafe inline is still heavily used today. And in my example earlier, Hotjar still uses it. So if you look at their documentation, their implementation uses unsafe policies. So it's important to weigh the benefits compared with the risks before deciding to use that third-party app, for example. So I guess you might ask me, is there a time when using unsafe inline is okay? And surprisingly, my answer will be yes. Actually, sometimes you can use it. It's only okay to use unsafe inline when it's combined with the strict dynamic directive. What does that mean? Strict dynamic allows the execution of scripts dynamically added to the page as long as they are loaded by a safe, already trusted script. So we can load them as long as we know that they are trusted. Now, kind of before ending my presentation, I wanted to share a link with you. This CSP evaluator. It's basically quite a cool tool where you can, I'll paste it, let's see, put it in the session here. So you can play around with this website. And inside, if you type in any website, it will basically tell you if you have any security policies in place for your website, and then it evaluates your policies, and it points out if you might have some vulnerabilities. So it's quite cool to play around. I did a couple of them before the presentation, but yeah, you can go ahead and play with it. So this kind of takes me to the end of my presentation, and I hope I managed to give you an idea of the principle of content security policies. I found it very, very daunting at the beginning, but then as I started reading about it, I realized it's actually not too difficult. So hopefully my presentation today will kind of give you an idea of what it is, why do you need it, and how to implement it. I'll be hanging around in the chat, see if you have any questions. But other than that, I thank you very much for taking the time today.